we get to finish or keep talking about our inverses, which was that whole first section of chapter 5. So in 5.1.1, we looked at inverses, looking at them algebraically in order to switch the x and y's and then solving it for y. So today, when it comes to the inverses, we're going to sit there and look at a graph and see if we can find the inverse off of looking at a graph. So we know that when it comes to inverses, like we're undoing the rules that we started with. And then we're going to learn that when it comes to inverses, when it comes to graphs, it's actually a line of symmetry. We're reflecting it over that y equals x line, so we'll talk about that a little bit. And I don't know if we'll get to writing the equations to inverses. A little bit. We'll get to that. Yep. So we just have 3 problems that we're doing some notes on. On the lesson plan, there is a link to where it just gives you the link to those 3 graphs that we're going to talk about. Not that you need them, but they had it as a PDF, so I just attached it for the fun of it, for poops and giggles. Sound good? All right. So when it comes to our inverses, like the textbook kind of goes through like a little scenario about if you were buying a car, like what are some of the variables that you think about when it comes to buying a car? You might think, you know, the color of your car. Maybe it's the color of your car. Maybe it's the cost of the car. Maybe it's fuel economy, right? Especially now that you guys might be at that age of getting cars and maybe you have to buy your own gas. So looking at fuel economy might be something to look at. So when it comes to fuel economy, there's kind of 2 different ways you can think of it. You can be, well, you know, like how many miles can I go on how many ever gallons I have. So you look at the tank, you figure out how many gallons of gas your tank is going to hold in your new car, and then you figure out like how many miles you can go. The other way you can think of it, it would be the inverse of that, or undoing that and going backwards. It would be, so I know that I drive this many miles, how many gallons of gas do I need in order to be able to go that many miles? So sometimes if you travel like a long distance, like let's say, you know, after you guys get your degrees or whatever, you're out in the workforce, maybe your job causes you to travel a lot. So then it's like, well, do you find a vehicle that has a larger gas tank so you fill up less amount of times? Or do you find an economy car with a small tank and you might get better fuel mileage, but you got to stop more often to get gas? So things to consider, right? So today we're going to kind of look at them on a graphing standpoint. So in lesson 5.1.1, we looked at these functions and then we sat there and we found the inverses using algebra. So if we started with our little equation that they give us, if I were to graph this equation, I know that I would get a line, right? And how do you know you're going to get a line? Yeah, it's written in slope-intercept form, right? And our degree on our x, oh, I'm lagging again. There we go. Our degree on our x is 1, so we know it's going to give us a linear function. It's going to have a slope of a half. And we also know it's going to cross the y-axis at a positive 3, right? And that's the graph that they ended up giving us. So last week, or in section 5.1.1, we took our equation that y equals 0.5x plus 3. And when we wanted to find the inverse, what was the first thing we did? Switch the x and y's, right? And then we ended up with x equals 0.5x plus 3. Whoops, I'm a dork. Y plus 3, right? And then we wanted to solve it for y, so we subtracted 3. And then to get rid of the 0.5, we can either divide by 0.5, or that's the same thing as a half, so we can multiply both sides by 2. So you'd have like 2x minus 6 equals y. Just jumping off, putting a couple little things together, right? And then we could go ahead and we could graph that equation, we would know that we would cross at -6. 1, 2, 3, 4, 5, 6. And we'd have a slope of 2, so rise 2, run 1. And we'd get a graph that looks, can't even see it. Ooh. And we would get a graph that looks like this, right? So that would be doing it using algebra. But instead of doing it through algebra, they want us to look at the graph and see if we can kind of figure out how to find the inverse without doing all of that algebra. So then we can get into some nasty looking functions maybe and not have to worry about all of the algebra. So I'm going to erase this and we're going to start over, right? So just like last week, when the first thing we did when it came to writing the inverse, oops, I don't want brown. We took our x's and y's, and what did we do? We flipped them, right? So wherever there was an x, we wrote a y, and wherever there was a y, we wrote a x, right? So now when it comes to our graph on our line, a line is made up of what? Points, a whole bunch of points, right? Really super close together, and they're so close together it looks like a line and not a whole bunch of points, right? So if we can find all of our points, and our points are x, y coordinates, so if we find points and then we switch those around, we can find the inverse. So let's talk about some points on our graph, right? So let's go to here. So it might be a little hard for you guys to see. So let's see if we can figure out that point. So what's my x coordinate going to be? 1, 2, 3, 4, 5, 6. -6. And what's my y value going to be? 0, right? So I started with the point -6, 0. And if I wanted to find the inverse, what am I doing? Switching the x's and y's, and what do I end up with? 0, -6, right? So let's try that for some more points. Let's go with this one. Uh-oh. There we go. So that point would be negative, what, 1, 2, 3, 4, positive 1, -4, 1. So -4, 1. And if I wanted to find the inverse of -4, 1, I would get the point 1, -4. Good job. Yep. Now let's try this guy. X is going to be 0. Y is going to be 3. So that would be the point 0, 3. The inverse would be 3, 0, right? And then just for the fun of it, let's just do that one more. So this guy would be what, 2, 4? Inverse would be 4, 2. So now what do you think we're going to do with all of those green points? Put them on the graph, right? So let's see if we can do it. So 0, -6. 1, 2, 3, 4, 5, 6. 1, -4. 1, 2, 3, 4. 3, 0. 4, 2. If I can draw a straight line, which, you know, sometimes you guys got to use your imagination in my class, right? And is that the same line that we got when we did it algebraically? Yeah, it's the same line, right? So when we find the inverse, there's actually a line that we are reflecting this over, and it's called the identity line. And the identity line is that y equals x line. So if y is 1, x is 1. If y is 30, x is 30. And so if you were to plot that point, we're going to go gray. Or to plot that line, that identity line goes right through, halfway through the first quadrant and like halfway right through that third quadrant. So when you're finding inverses, you're always reflecting it over that identity line. And if it was perfectly drawn, you know, it'd look nice and cute. So on a nice little linear one, it's not so bad to sit there and switch the x's and y's and do it algebraically. But you want to spice it up a little? Whoa, look at this guy. Right? Uh-oh, maybe. We know this one's a quadratic. How do we know it's a quadratic? It's a parabola, yep, and if we looked at the equation, it's to that second degree, right? So that's telling us it's going to be that quadratic. Right? Our vertex, because it's in vertex form, our vertex is going to be at -2, -6. Right? Our A is positive, so we know it's going to open up, and our A is greater than 1, so we know it's going to stretch it, so it's going to be a little bit skinnier. So I'm going to run through the algebra real quick on this, right? If we were last section, if we had, y equals 3x plus 2 squared minus 6. If we wanted to find the inverse, we're switching that x and that y, right? And then we're going to solve it. And you guys don't have to write this all down. And then we're going to solve it for y. So I'm going to add 6 to both sides. Right? Then I'm going to divide by 3. It's lagging really bad now. Yeah? And then I'm going to take the square root of both sides. Oops, I screwed that up. So now we got x plus 6 over 3 equals y plus 2. Then I'm going to subtract 2, and then I got the square root of x plus 6 over 3 minus 2 equals y. Right? Now I need you guys to plot some of those points off of there. You know, pick an x, plug it in, get an answer, figure out the y. Not the funnest of activities to do, right? So on a problem like this, it might not be easy to solve it algebraically. It might be actually easier to solve it by looking at points on our graph and flipping them and plotting them. So let's use our imagination a little bit and see if we can kind of think about it. So we know that we have to reflect this over that identity line, right? That identity line was kind of halfway through the first and the third. So somehow we have to reflect our parabola over that line. Anybody got any guesses on what it's going to look like? Where is it going to go? What's it might do? What do you think? What was that? Yeah. Let's see, right? So I'm going to erase all the algebra so we got some room. So if we wanted to find the inverse, looking at our graph, we need to find some points, right? I think we know the vertex. What's the vertex going to be? -2, -6, right? And if I wanted to find the inverse, I'm just flipping them, so the inverse is going to be, yep, good job. And then we got this point here. What do we got? -3, -3. I know finding the inverse of this one might be a little bit tricky. Anybody got any ideas what the inverse of -3 and -3 is? -3, -3. Right? Whoop. Put that one on the quiz question, right? What do you think of that? This guy's going to be what? -1, -3? Flip that baby for the inverse of -3, -1. And they helped us out because they found those perfect little points. Like normally you'd kind of have to maybe play around with your graph a little bit to find those perfect little points, but they showed us all them to us. So here we have what? -1, 2, 3, -4, 1, 2, 3, 4, 5, 6. -4, +6. If I screw these up, you gotta let me know. Inverse, we're just flipping them. So we get 6, -4. And then what's this guy here gonna be? What's that last point? X is 0. Yep. 0, 6. The inverse of 0, 6 is going to be 6, 0. So now we got to plot these points, right? I'm going to go orange. E. Okay. So -6, 1, 2, 3, 4, 5, 6, -2. All right, that's not orange, that's brown. We'll deal with it. -3, -3, we already had that point marked, so I'm going to mark that one. -3, -1. And then 6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And 6, 0. So we know like the shape isn't going to change. So we know we still have to have some kind of parabola looking guy. So we got this guy. You gotta use your imagination in my class. Sometimes you gotta make your dots a little bigger when we're sketching these. Right? Not too bad. So is that what you thought it would look like? No. Not two shabs, right? And then we can even get into some more funky ones. Right. There's this whole guy. Anybody want to solve this one using some algebra? Nah, I'd go ahead and find some points on this one, right? And it's kind of, if we take what we learned up on here, how it kind of took our parabola and it kind of like flipped it over like to the right. So we could kind of use that same theory when it came to this one. When it comes to after you would plot those points, you'd be like, all right, I know it's got to kind of somehow shift it over. It's kind of like that rotation to it, right? You guys good on flipping your X's and Y's and graphing those guys out? On problem 52, sometimes we have to be a little careful when it comes to making our inverse functions. If we start off with what they gave us, that we're just going to change it to y equals x minus 3 squared. If I were to graph that, what am I going to get? A parabola, yep. Where's my vertex going to be? It's almost in that graphing form, right? H and our K. So our H is going to be 3 and our K is going to be 0. So at 3, 0, right? And it's going to open up. So it's going to look along this line, right? So from what we kind of learned previously, right off of this guy, when it comes to finding our inverse, we know that this our vertex is at 3, 0. So if we were to find the inverse would be at 0, 3, right? Oops. And we think it should kind of go like this and like this, right? If we were to solve this one algebraically and we switch our x's and y's, we get x equals y minus 3 squared. Right? And what's the first thing we got to do? Square root both sides, right? So you get the square root of x equals the square root of y minus 3 squared. So now we got the square root of x equals y minus 3. Add 3 to both sides, and we get the square root of x plus 3 equals y. So question 8, it says to be careful on your domain. Are your domain your x values or your y values? Your x values, right? So we got to look at our x values and see, ooh, where's my error? So we're looking at that x value and seeing if there's any restrictions on that x value. Can anybody think of any restrictions that might happen on that x value? What do we know about square roots? Do we want our values in there to be positive? Yeah, we want to make sure that our x values are positive. Because we can take the square roots of negative numbers, but they're imaginary. And when it comes to graphing like right now, we're just sticking with real numbers. So when it comes to the domain, we just have to be careful that our x's, if we got the square roots, are staying positive. Sound good? So I'm going to give you a problem that's got 2 graphs on it, or 2 functions on there. And then I want you to see, do you think these guys are inverses of each other? I'm going to blow it up now. Just kind of from what we picked up on figuring out our inverses, and our inverses being that reflection over that identity line, that y equals x. Do you think these guys are inverses of each other? Yeah, looks like it, right? Which one's the function and which one's the inverse? Could this one have been the function? And then we reflected it over the line to get the second one? Could this guy have been the function that we flipped it over to get the other one? Yeah. So when it comes to graphing these, we have to be really careful in making sure that we are labeling our graphs so we know which one is the original function and which one is the inverse, right? So our book always does a nice little job of giving us these little math notes right in the right spots. So it had to do with that whole notation of inverses. F of x. F of x is going to be our function. So when you're making a graph, wherever on your graph, once you graph that function, just write that little f of x somewhere by that graph so you know that one is the function. And then our inverse notation, that f to like that negative 1 of x. And we have to remember, like, that's not to the negative 1 power, right? That's just saying that that's the notation for inverses.